day 3 of understanding LLM applications on Databricks. Earlier videos we have seen what is this generative AI is all about and how it has evolved over time. Then in the next video we have also seen what is prompt engineering, what is a language of communicating with the large language models, that is prompt engineering. And then with basic prompt engineering, it was not sufficient. So we went one level up, and we also tried to understand what is uh, advanced prompt engineering, where we learned like chain of thoughts and how to pass the prompts in the right way with giving right role and everything. So because of that, we could extract the information from LLM. But then, what is the use of all these things? Is to build out or integrate into an application, and that's what we are going to see. The reason why we are trying to learn all these things on Databricks is because Databricks is particularly a very powerful platform because uh, data code models and serving data code models and serving endpoints, notebooks, everything is present and packaged in one workspace. So you don't have to go to four places, like just build out an app, build out an endpoint, get some key, put it somewhere. All those things you don't have to do. So everything, like the best world class LLM is available as an endpoint, you just need to use it. And in this video we are specifically going to learn how to use them. So everything lives at one place in simple terms. Therefore Databricks is a very powerful platform. No need to wire up external APIs or maintain scattered infrastructure. Students can build, test, and deploy LLM apps in the same environment. There is a word which I just want you guys to understand is LCEL, which is LangChain Expression Language. So first of all, we are going to understand how to set up an LLM client. So whenever we are trying to do any kind of interaction with an LLM endpoint, we definitely would want to create a client out of it, and then from that client we can use we can do an interaction. So we begin first by installing the right libraries. We install something called LangChain Community. LangChain Community, as I mentioned in my previous video also, is a library of LangChain provided by LangChain Community. And the LangChain, as I mentioned in my previous video, is a library provided by LangChain Community, and that has a specific module for Databricks. So I already ran this install command, which will install LangChain in my serverless option. So you don't even need a very huge cluster. Whatever serverless option that is provided by free Databricks version is more than sufficient. So we installed everything. Now what we are going to create is a LLM client. How we create LLM client is we already have a module in LangChain community called Chat Databricks, and we are going to use that module Chat Databricks. We are going to pass the endpoint. The endpoint that we are going to use is already available as an in the Databricks free edition. The endpoint name is Databricks MetaLlama 3-3 70 billion parameters, and it's an instruct model. Whatever instruction we give, it act accordingly. And then there is another parameter which is passed called tokens. Once this is run, an LLM client is created. So automatically, you don't need to put down any kind of key and tokens, and you don't need to spend a lot of money. So it will be available as a client. Now, next, what we are going to do is we are going to create our first application using a simple LCEL assistant called LangChain Expression Language. The first app that we are going to create is we are going to ask a question and then try to get an answer. So what we are using another library, another module called prompt template. Within prompt template, we are passing the prompt, that is, you are a friendly assistant. We are giving the role to an LLM and asking, please answer the question clearly. So do not hallucinate and try to answer it clearly. The question that we are passing uh, is put in the form of variable, and in the next line what we are going to use is something called LangChain expression language. So that in whenever we are building any LangChain application, we should know these three fundamentals: input, logic, and output. Input is going to be your prompt, okay? Logic is going to be inside LLM, and then whatever is the response will be the output. So what we do is we created something called prompt. It's a chain language, so prompt will be passed to LLM. It's like that. Prompt will be passed to an LLM. So prompt is then passed to LLM, and for that prompt is prompt is then passed to LLM, and uh, for that the question is being asked, what is delta lake? The question will be replaced here. Automatically the prompt will be generated. You are a friendly assistant, answer the question clearly. What is delta lake? This will be a complete text that will be passed to an LLM. Whatever response you get, we are just trying to print the response. So based on his knowledge, LLM's knowledge, it is trying to print the answer. So it has given like delta lake is an open source storage layer that brings reliability and performance to data lakes. It was developed by Databricks, company founded by original creators of Apache Spark. So whatever is the basic information that is available to an LLM, it is going to try and answer. Moving to another set of a type of an LLM application called chat interface or chatbot. Now there are different variations of it. We will just try and understand the simplistic way. There is another library in LangChain core called human message, and we are going to use that library. What we are going to do is we will run a loop, and within that loop what we are going to ask is uh, we are going to use something called history, where we right now don't have anything, but as and when we start asking the question in that particular session, we'll start collecting that information, we start collecting that messages. Okay, so what we do is history dot append human message and content input. Whatever is the user input, that will be passed as a human message. An object will be created that will be appended in a array of history, and then we pass that complete history to an LLM, and then ask it to answer. This is specially used when we are chatting, right? So whenever we are chatting, LLM should know what was the earlier question so that it can understand the context and try to answer you in a right way. If you don't pass the context, it will treat every question as new. So therefore this type of arrangement is being made. So if you run this, since this is a Databricks notebook, it will block that particular cell. So we'll just check. So let us try and understand what is LLM, and then let's enter. It will try to answer in the best possible way. Yeah, it has answered. And then let us understand what is the applications of LLM. So it has given LLM applications. So within that context, it tried to answer. What is LLM? What are the applications of LLM? Let us try to ask something different. Who is Sachin Tendulkar? And I am trying this for the first time. Let us see what it answers. Yeah, it answered whatever is based on his knowledge. It tried to answer, and it has not related to the previous question, but then uh, it the model that we are using is an amazing model, and therefore the model that we are using is an amazing model, and therefore um, definitely this is very useful. The model that we are trying to use is a very mature model, that is Llama 70b. It's trained with 70 billion parameters, therefore it is not hallucinating. Otherwise the earlier GPT version used to give a completely different answer. Moving to the fourth type of app, which is a summarization app. So let us just interrupt this, otherwise it will not allow us to run the next set of application within the notebook. So let's move ahead. Now we'll try to understand what is a summarization, one of the easiest LLM app. Most real LLM applications start with summarizing the long text, because even now I see many of my colleagues are just like posting their email conversations and everything into that and try to summarize and get a gist of it. Even the documents they do. So one of the common application which distinguishes LLM application from the previous machine learning model is it can generate, it can summarize, it can understand. So a summarizer is also a perfect beginner application because the input and output are completely predictable. So in this case, what we have done is we have given something like long text, and that long text we are going to pass it to a prompt template. And what we are saying is summarize the following in 4 to 5 sentences, focusing on clarity, and we are passing the long text to it. The moment we pass the long text, we are going to get the summarizer prompt. It is nothing but summarizer prompt is nothing but a general prompt that we have seen in the earlier application. We are just creating that prompt. So the moment this invoke happens, the LECL triggers in, LangChain expression language triggers in, and summarizer prompt is then being completely created. Summarizer prompt is this. Within that you have a variable called text. So you are passing this variable in the invoke. You are already passing this variable. It will be replaced with long text, and what will be a complete prompt is summarize the following in 4 to 5 sentences, focusing on clarity, and this is my text. Once that is passed to an LLM, the output will be shown. So this is the output that is being shown. So earlier the information is related to delta lake, and it is also giving the information on delta lake. So let's say summarize in just, let's say we ask them 1 to 2 sentence. Let's try to run this. It should reduce the size of the output. Yes, it has reduced, and it is just saying that delta lake is an open source storage layer that adds reliability to data lakes by providing features like ACID transaction, unified batching, and stream data processing. Is compatible with existing systems such as S3, ADLS, and GCS. So earlier you must have seen that it was giving a summary in 4 to 5 lines. Now it is giving summary in 1 to 2 lines. So you can then play with this prompt. The more you start playing with the prompt, start using the advanced prompt engineering technique, the much better the reply you would get. The next set of application for LLM is extracting the information or turning an unstructured data into structured one. Extracting apps are extremely common in enterprises. There are many places in an enterprise where you get the data in the form of an unstructured, like PDFs, or even for that matter sometimes you get as a text documents and all. But then unless in that information is converted from unstructured to structured, the standard ways of pulling out insights from data is not applicable. And therefore there has always been a case that whenever you have such a scenario where you have unstructured data present, you definitely have this inner feeling that you would want to convert immediately into the structured data. And LLM has been amazingly beautifully extracting the data, because the earlier if you don't use LLM, the extraction is quite mechanical. You just have to go and tell scrape this part as is. Okay, so this is the way we generally extract. But with LLM you have the capability, because you have an understanding of text, you could do a amazing extraction using LLM. And that's where LLM application are being used a lot. So what we will try to do is we will pass on something called customer message. What is the customer message? Hi, my order is arrived late, the packaging was damaged, I am really disappointed, and my name is Sarah Thompson. I expected this to be fixed. Now what we would want to do is, there is an extract prompt that I'm generating. So I'm using something called advanced prompt engineering, and I'm putting a right prompt. So what is the prompt? Extract the following fields from the text. But I am giving a very specific instruction, which is return only a valid JSON. So whenever you are returning an output, you should return only a valid JSON, and these fields should be present in the JSON. So in a way, we are telling that you should always try to extract these three information from the JSON, and then give me a structured JSON. So for example, issue, customer name, and sentiment is something I want to extract from it. Again, I'm using LangChain expression language, and LangChain expression language where I'm generating a prompt. It's a structured prompt with right kind of fields and everything being set, that is being passed, and then even the customer message is then passed as an input. Now, since LLM is having the right set of instruction, the response that you are going to see is not going to be a free flowing text, but a structured JSON. Okay, so this is the structured JSON. Now another set of application, next set of application that we are going to see is classification, uh, turning languages into categories. So for example, let's say you receive the data, and there is always a need to categorize it. Okay, sometime it might happen that, let's say you are receiving the data from multiple sources, and based on the text you want to categorize and pass it to a right application. So for example, let's see what is there. So we, based on the text, we would want to understand whether it's a compliment from a customer or whether it's a complaint from a customer, and then we would redirect it to a complaint department. So LLM is extremely useful in such cases. Now what we are trying to ask here is, like, if the customer is having a particular set of message, to what department you should route. And therefore what we are sending to an LLM is a text and labels, whether it's a complaint, query, or appreciation. And you don't have to tell, like a machine learning, you don't have to train any model, you don't have to tell that, okay, if these keywords are being used, then do this, do that, nothing. You just pass this in a right format using the right set of prompt, and then you would be able to get the answer. So what is the prompt that we are passing as an instruction is, classify the message into one of the categories. These are my labels. So these are labels, and this is my text. And then return only the category name. So this is a very specific instruction that we are giving and would expect an answer. The answer to that is complaint, because user is saying my refund is delayed and isn't supporting. So that way we can uh, we can we can we can categorize the product. So let's change it. You gave me amazing service. Okay, so just let's try to run this appreciation. In machine learning, I would have to sit down, train the model, push the data, make sure that its accuracy is there, score is good. But in case of LLM, it's a one step ahead. So that's the difference. And I'm able to do this with just simple set of 8 to 10 lines of code on a Databricks platform is another amazing thing I just wanted to highlight. Moving on to next set of application, which is SQL plus LLM app. So already Databricks is having access to your cluster. Your cluster might have an access to Unity catalog, and with that, your LLM would have knowledge, would be able to get the knowledge of whatever Unity catalog in or tables and uh, schemas are available, and using that it can generate the query. So for example, we are saying you are a SQL generator for Databricks. User question is this, translate it into SQL and run that on the Unity catalog table. So if I run this, it is going to try and search in my catalog, whatever catalog it has access to, any customer table, and then with the customer table, the moment it will get, it will try to understand the table, generate a query, and then run the query and even create the, this is the query that it has generated, and then it has even created the results out of it. Okay, so this is the kind of beauty of LLM applications is there. If you bring it all together, by the end of the topic 3, what all things we have learned is like using LLM as a chat assistant, a text summarizer, a structured extractor, and then a classifier. We have classified it, and a SQL generator. These are like a very, very powerful applications of LLM. Each one is only a few lines of code, yet each represent a real pattern used in production Databricks LLM systems. LLM applications aren't huge systems. They are small, clear ideas turned into chains using a very powerful framework called LangChain. This mindset prepares them perfectly for next topic is agentic systems. The next topic that we are going to learn is agentic system. When multiple chains start working together, and LLM gains the ability to reason, decide, and use tools. There is another video which I have prepared, like what is agentic mindset is, these are the these are isolated LLM application, but a decision doesn't happen on that, right? Like once the SQL is generated, results are generated, we may want to summarize it, so we may want to combine couple of things together. And what is best if the LLM itself can do it and just give the final answer. It can plan these multiple steps, do it, and give the final answer. So that is what agents do, is what we are going to learn in the next set of videos. Thank you guys for listening to this. Please do subscribe. This is all done in Databricks free edition account, where you don't have to do any kind of setup of LLM endpoints and all. It is directly available, and even you can do it with a very small compute serverless, which is freely available. Thank you for listening. Thanks.